Today, we will complete the table of values for sine. So once we completed this table right here, we should be able to sketch the parent graph of a sine function. As you can see here, I have placed the little question mark next to the sine here. What we're solving in order to get the sine is how high the ladder is. So that's a question mark right there. Now others are going to say, what do we mean by ladder? What ladder are you talking about? So I will give you a short story over here to better understand and to make this more visual. So in order that we can graph everything here, so I will explain to you what is this. So this is like a ride, like a Ferris wheel, and then each of the a little background about this one. Half of this ride is actually under the ground, so that's why I'm putting dots here. That means it's under the ground, and the other half is above the ground. So that's one of the features of this ride. Now another feature, from the center to where the seats are. By the way, these are where the seats located. So this is where you sit if you would wanna be on this ride. So this is where you sit, and so from the center to the seat of the ride is 1 unit. So that's why we have 1 here. So I can label this as 1 and 1. So and 1. So all the rest would be 1. So that's 1 unit. And then another thing that we need to remember is the angles. So the angles that we have here is actually the angle formed from the ground to the rod that holds the seat. So this one's right here is 30. So then if I go over here, this is 45. So that's how we got these angles here. Okay, and then another thing, in case of emergency, they have planned an evacuation process in order that there's like, if for example this ride is gonna stop, they need to evacuate somewhere by following a method of exiting. So each of these seat here, they have their own ladder for exit. So that's the exit ladder for 30. That's the exit ladder for 45. This is the exit ladder for 60. So if you are at 60, 30, or 60 or 45, somebody or these people that are seated in here need to go down to exit. Now, if the same thing for 135 and all the rest of these. So they need to exit through the ladder. They need to go down. Now, for those who are located underneath the ground, let's say 240, so they need to exit by climbing up the ladder. So they need to go up the ladder and exit. So here they need to go down the ladder and exit. This is the reason why I have a little note right here that says the height of the ladder above the ground is positive. So all of these ladders here would be positive, and those that are below the ground, like 300 here, there's an exit ladder, so the person needs to go up there and exit. All of this ladder measures here would be negative. So it's telling us they're under the ground. It's negative. If it's above the ground, it's positive. Now, we are ready to determine how high are each of these ladders. Okay, so we're going to start first with 0. So at 0 degree, what is the height of the ladder? So that's the first here. So from the ground, they go in. So there's no height for that. So we can go ahead and say this is 0 and 0. By the way, there are two numbers, or there are two y values that we have over here. So the first y is the rounded. The second y is the exact value. Now let's have the 30. So I have actually graphed this. I actually have created a triangle that would match the 30 here. So let's say that's the 30 degree angle. So there is this ladder here. So we need to determine how high is this ladder. So I'll put that over here and we will solve for it. So I'm gonna have a piece of paper here for all of our work. So as you can see here, so if I put that over here, so we have this side right here will be we look at the others are going to say, how do we determine the values here? So first, this side is the hypotenuse. This unit is, or this value is 1. And we want to determine the height of the ladder. So let's assign this as letter Y. So what are we going to do now is we are going to label the parts. So this one right here is our hypotenuse, and this one right here is our opposite. So if we have a hypotenuse and opposite, that's SOHCAHTOA. So this is going to be so. So we're going to use sine for this. So to set it up, it's going to be sine 30 degrees equals, that's going to be opposite y over 1, which is the hypotenuse. So then we can go ahead and write y equals sine of 30 degrees. And so the values that we can have here will be, we need to check on the calculator. Let's use the calculator to find the value for this. Just a reminder on the calculator, which I have attached this on Google Classroom, the link for this. The first thing that we are going to do here is be sure that this is in degree, because if this is in radian, you're going to get it wrong. So that should be in degree. Next, we are looking for sine 30. So what I need to do is to type it in, sine 30. And that is the value right there, 0.5. So then I'm going to write here 0.5, and this is the value that we have here. So I'm going to write it up here. This is 0.5. Now, how do we get the exact? The exact value would come from the special right triangle. So the rounded value are the ones that we solve, and the exact value are the ones that we can see outside of this special right triangle. So just by looking at this problem right here, we have a 30. So I go to 30, and then I want the opposite, which is y. So I wanted to know what is that. So I go to 30, and then the opposite of 30 is 1/2. And so I can go ahead and say this is 1 over 2. And that makes sense, because if you have a 1 divided by 2 is 0.5. So let's move on to the second angle, which is 45. So I put that in here, and then I got the 45. I labeled it. So this is the ladder that we need to determine. And again, the length of the rod that holds the seat is 1. So I'll put that in here, and let's label the parts. So first here would be 1, and this is our y. That's the one that we wanted to know, the height of the ladder. So this is actually the opposite of 45, and this is the hypotenuse. So again, we are going to use so for this. So to set it up, that would be sine 45 equals opposite, which is y, hypotenuse over 1. So then we can go ahead and say y is equal to sine 45. And if we use the calculator, that would be equal to y is 0.707. So please use your calculator to determine that value. Now, what are we going to do? So we're going to write it over here. So that is 0. So this is 0.707. And so I can go ahead and determine the exact value using the special right triangle. So 45 opposite to that is 45. So go 45 opposite to it is square root of 2 over 2. So then in here, this means that this is actually square root of 2 over 2. We can actually check on the calculator to see if these values are equal. So let's put in the value here. So first we have square root of 2 divided by 2, and that's divided by 2. So then that value is 7.07. So this is the rounded, this is the exact. Now let's move on to the third one, which is the 60 degrees. So I have here another paper. So for the 60, and I have placed this one up here. So that's the triangle right there. And again, we want to know the height of the triangle. So I will put that up here. So this is, the label for this would be 1 on the hypotenuse, and this will be our y. Again, this is our opposite, and this is our hypotenuse. So then to solve for this, we are going to use opposite and hypotenuse, so that is a so. So then sine of 60 is equal to, that's gonna be y, which is the opposite, over 1. So y divided by 1 is just y. And so sine 60 is actually 0.866. Again, you can use calculator for this. So 0.866. So I am going to put that up here. 0.866. And let's find the exact value for the y. That is 60. We want the y is actually the opposite of 60. So I go here 60. So this is 60 right here. The opposite of 60 is square root of, that's the square root of 2, no, square root of 3 over 2. Now let's check if the answers are a match. Square root of 3 over 2. So what we do is we put that into the calculator over here. So that is a square root of 3 divided by 2 is a 0.866. And that's the value right there. And let's have the last one here. Let's take the 60. So 90. So we're done with 60. We move on to 90. So for 90, the height of the ladder is actually equal to the radius, because that's 1. So this one right here is a 1 for 90, and that's a 1 over here. Now, I know others have seen the pattern already. So they have seen the pattern on what's going on here. So if you look at let's start with 60. So if we got 60 here, so what's going on here is that this is the height of the ladder. The height of the ladder for 60 is actually the same as the height of the ladder for 120. And it's also the same as the height of the ladder for 240. And it's also the same as the height of the ladder for 300. So it's like a repeat. So the 60, 120, 240, and 300 will have the same height. The same thing for 30. So if I got 30 here, that's the ladder. It's the same height as the 150. It's going to be the same height as 210 down below. It's going to be the same height as 330. So the values here are just gonna repeat. We call the first quadrant, we only determine the first quadrant here. We call the first quadrant as the reference angles. I'm gonna label that over here. They're called the reference angles. They're called reference angle because once we know these measures here, we will know the rest of the measures around the circle. So let's have the list of all of the angles that will have the same ladder height as the reference angle. So I have here the list. So let's start with 30. So if I have 30, all the other angles would be 150. So that would be the same as 150 degrees. And that would be the same as 210. And then that would be the same as 330. And then for 45, that would be the same as 135. That would be the same ladder height as 225, and that would be the same ladder height as 315. For 60, that would be the same as 120, that would be the same as 240, and that would be the same as 300. Okay, so let's have the values for some numbers here. Let's put in some numbers in the table. Let's put in some values. We start with 120. So 120 is similar to 60. So I go ahead and write this. So therefore, this is 0.866 and square root of 3 over 2. Now let's try 135. 135 is the same as 45. So this would be 0.707. And then this is square root of 2 over 2. Now I will skip 150. You do it on edge elastic, and then you go 180. 180 was the height of the ladder. Correct. It is 0. So that's a 0 right here. And let's start with 210. Let's do it all together. So 210. So 210 matches up with 30. So I go to the measure of 30 right here. That's 0.5, and that is 1/2. Now, I am going to put a negative. Why is this 210 a negative? Again, this is negative because this is below the ground. So starting from 210 all the way to 330, they will come out negative because below the ground is negative. Above the ground, we stop at 180. These are all positives. Okay, so let's start with 240. Let's do 240. 240 is the same as 60, so that would be 0.866, and that is square root of 3 over 2. So again, this is negative. Again, the purpose for that is it's below the ground. So I will let you do 225, 270, 300, and let's do 315 together. So 315 is the same as 45. So I look at 45. So that would be 0.707, and this is square root of 2 over 2, but these are negative again because it is below the ground. Now let's do the 360 together. 360 right here. The height of the ladder here is 0 and 0 because that is a starting point. So we already have filled it in. So those blanks here, I'd like you to go to Edge Elastic and fill it in. Now, once we have completed everything, we should be able to, once we graph this, the X are the angles and the Y are the height of the ladder. Once we graph it, we should be able to see the shape of the parent graph for sine function. If you think this video is helpful, please like and subscribe for more math videos. See ya!